All right, so this may be the last video, guys. It may be. So we're putting it all together, and the direction word is just going to simply say factor, and we have to know how to factor. So what I've pulled up here is, this is the sheet that I'm going to keep referring to when I do these problems. So before we even use this, first thing we're always going to do is look for a greatest common factor. Always. Many times there won't be one, but we're still going to look for one. Second thing we're going to do is count how many terms there are, because this is going to be a big key to what we do next. If we've taken out a GCF, then what we count are the numbers left over in parentheses after we've taken that out. So if there's only two terms, the only way to factor two terms is if it's a difference of squares. So like this, if it was 4x squared minus 25, the only way we could do this is to say, well, then that has to be a perfect square, that has to be a perfect square, and it's a subtraction sign. If it is, well, we know how to factor it. If it's two terms, and this one's not a perfect square, and this one, or this one's not a perfect square, or that's not a minus sign, then we're going to say it's prime, and we can't do anything further. If there's three terms, first thing we're going to say, and keeping in mind we've already taken out a GCF, is it a PST? So I'm checking for the first and the last to be perfect squares, with that being a plus sign. If it is, we're going to make our one set of parentheses, take the square root, and double check for the middle. If it's not a PST, then we're just going to try backwards FOIL. Sometimes it'll have a coefficient, sometimes it won't. Okay, but if it doesn't work with backwards FOIL, we're going to say, okay, it's prime. Now, like I said, there are other ways to factor. We're just simply not going to have time to do those, okay? This other thing you're going to love when you get to high school. It's called the quadratic formula. I might add a video on how to solve using that, just to make it less intimidating for you, but we're not using that. So what we're using is primarily this first page of the handout. Okay, so all I'm going to do on this video is work out problems that use these steps. Okay, so the first one, 5x squared plus 25x plus 30. Okay, so our first thing on the handout says look for a GCF. If I look here, there is a GCF. 5, 25, and 30 can all be reduced by 5. So I'm going to take that out. Okay, so I now have at least factored it that way. After I take it out, I look in the parentheses, and it says, after you take it out, count the terms. If there are 3, check for a PST. Sorry, I don't mean to be making you seasick here. I hope I'm not, but I'm going to be going back and forth. Well, that's a perfect square, but that's not. So the handout says, well, okay, maybe it's not a perfect square trinomial, but can we use FOIL? So we're going to bring down this 5 because that's part of the factoring, but we're going to see, does FOIL work? And I would be able to split up the x's. I'd look at the last sign, and it's a plus, so that means they're both the same, and they're both going to be plus. Now, is there two numbers that multiply to be 6 that add to be 5? Yes, 3 and 2. Okay, and I'm always going to look in the parentheses that are left over, because I'm looking to see, do I have any common factors, or can I go further with them? And in this case, we can't. So there's your factorization. Okay, second one I'm going to do. How about 2x squared minus 72? First thing I'm going to look for, GCF. Well, they're both even, so I can take a 2 out. And when I take the 2 out, I look in the parentheses. How many terms? 1, 2. If there's 2, the only way to factor 2 terms is if it's a difference of squares. Well, that's a perfect square. That's a perfect square. So it looks like it's a difference of squares. Take the square root, take the square root, 1 plus, 1 minus. That's how we fully factored the second one. Number 3, 12x squared minus 5x minus 3. I don't remember. I think I'm going off a different page that I worked out to make sure these work. Okay, so I look here. Is there a GCF? Well, there's a GCF between 12 and 3, but not of 5. So there's no GCF this time. So this time we have to make 2 sets of parentheses. We have to make a list of factors of 12 and a list of factors of 3. Split up the x's. Signs are going to be different. So I need the factors of 12 and the factors of 3 to match up to subtract to be 5. So what it looks like is 3 with the 3 and 4 with the 1, because 9 and 4 subtract to be 5. So I'm going to put the 3 and the 4 in here. I want the 4 to multiply by the 1, so it has to go in opposite parentheses. I want the 3 to multiply by the 3. Those are the outsides. So let's check the sign. We have 12x squared plus 9x minus 4x minus 3. Well, that gives us 5x. We want negative 5x. So our answer is going to be 3x plus 1, 4x minus 3. Okay, factoring completely just means I checked for a GCF, it wasn't one. I tried it, it's not a perfect square trinomial. I think I said that. If I didn't, I left it out. But we tried backwards FOIL and it worked. And you get this. There's nothing in common here. There's nothing in common here. The only way to factor anything here is if it's a difference of 2 perfect squares, neither one of those fits that. Okay. How about x squared plus 15x plus 56? No GCF. 1, 2, 3. First thing I'm going to check if it's a perfect square trinomial. That's perfect square, but 56 is not. So I'm going to try backwards FOIL. This doesn't have a coefficient, so I just split up the x's. They're both going to be positive. What multiplies to be 56 and adds to be 15? How about 7 and 8? And that's done. Okay, how about 3x squared plus 18x plus 27? Looks like a GCF, 3 goes into each one of them, so I'm going to take the 3 out. And I'm going to count the terms that are in the parentheses. Include that 3 that you took out. Well, that's a perfect square. That's a perfect square. So I'm going to try a PST. And in that case, the square roots would look like this. X and 3. Double the middle. 3x doubled would be 6x. So this is what it would look like for that one. Okay, 6th one. I got about 8 of these. Okay, x cubed minus 25x. Well, GCF. Well, I have x here and x here. So this time, and I don't have a number there, so this time the GCF is going to be an x. When I divide the x out, I get x squared minus 25. 2 terms left over in the parentheses. The only way I can factor 2 terms is if it's a difference of 2 squares, and it is. So I bring down that x. Difference of squares means the square root, 1 plus, 1 minus. A couple more. X squared minus 10x plus 9. There is no GCF. 1, 2, 3 terms. Well, 3 terms, I'm going to check for a PST. Perfect square and perfect square. So I'm going to try square root of x squared, square root of 9, take the middle sign. I got to double check. 3x and 3x makes 6x. That's not 10, so that is not the way to factor that. Instead, that handout says, if it's not a PST, then use backwards FOIL. So I'm going to split up the x's. The signs are the same. They're both negative. What multiplies to be 9 and adds to be 10? How about 9 and 1? All right, how about 2x squared plus 18x minus 28? Well, there's GCF. One, two, 3 terms. 3 terms is either a PST or a FOIL. Well, that's not a perfect square, so we're going to try FOIL. Signs are different. What multiplies to be 14 and subtracts to be 9? Multiplies to be 14 and subtracts to be 9. Well, if I put 7 and 2 in there, it's going to make 5, right? Positive 7 and negative 2, or negative 7 and positive 2. So I don't think we can do this. So that doesn't mean the whole thing is prime, but it means we can't go further. This itself is prime. We can't factor it, but we did take out the 2, so that would be the final answer there. Okay, I hope these, I tried to find various varied kinds of examples for you to see. But the point is, they are usually more than one step. You check for a GCF, but then you always have to check for something else, because chances are you're not going to be done after you take out the GCF. Okay, and a lot of these we had to keep going. Okay.